your default mask. A class A means 255.0.0.0. Slash A means the first 8 bits are network bits. Once you have the number of network bits, make sure you have the same number of ends down here. Class A is easy because the first 8 are already written for you. Cannot be less than 8. Next thing, find number of borrowed bits and host bits. Depending on your assignment, you will be given a number of networks to find or a number of machines in each network. So when you get one of those two numbers, take your subnet encrypt sheet, go down through possible for networks or usable for hosts. If you're giving hosts, use usable. If you're giving networks, use possible. Go down until the number is larger than the number you were given. My case, this case, we need to make 2,000 networks. So, go down through possible until the number is more than 2,000. That will be 2,048. Go right, go left. Find number of bits. 2 to the power of 11. 11 bits needed gives me 2,048 networks. Okay, then remember, this number, and this number needs to be 32. 32 because there's always 32 bits in the IP version 4. On the networks, for now, just take the number of bits and raise to the power of that number, 2 to the power of 11. Don't subtract. When we get a little bit further, there'll be all kinds of examples of exceptions. So once in a while you have to subtract once in a while you have to subtract 2, once in a while you don't subtract anything. We're not discussing all those rules right now. Just to make things a little maximum usable subnets. How many networks can I make when I have 11 subnets? What you're basically doing is saying, okay, I am defining I need 11 subnets. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The smallest number I can write on those 11 bits would be 0. The largest number I can write would be 2,047. And 0 to 2,047 gives me 2,048 different numbers. Those 2,048. 2 to the power of 11. Okay. What we need to find now is number of host bits. So if this number needs to be 32, this one plus this one plus this one needs to be 32. So take those two numbers and subtract from 32, then you've got this one, 13. 13 bits for hosts. Take my subnet encrypt sheet, go down through number of bits until I reach 13, go to usable. That is 2 to the power of 13 minus 2 because network address, broadcast address not usable. So 8,190. Take those 13 and say I need 13 ages. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 ages, 13 host bits. That actually gives you the mask of your network. Because in your mask, all n bits are 1s. So explain to the router that this is network bits. Then put in a 1. Oh, subnet bits are also network bits. So put in a 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Host bits are not network bits. So host bits needs to be 0 in the mask. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Take those numbers, write them decimal. 8 ones is easy, 255. 8 bits is easy, 255. 3 bits. Easy if you can it, 224. If you cannot, go to your mask table. Find where you have 3 bits and 5 zeros, 224. 0, all zeros are easy, 0. That is your mask. That is the one that tells the router where is your border between network bits and host bits. Let's make it all the way down. You don't need to make this one, but it can help you see what's actually happening. Okay, that was how is it actually subnet. Then we need to find the address of the 22nd network. 22nd network, first thing we need to do is find the number.
21.
Number 21. Because the first network always has number 0. So the second network will always have number 1. The third network will always have number 2, and so forth. Until we reach 22nd, that will have number 21. Take that number, write it binary. Write it binary somewhere else for now. 21 is 10101. That is the binary pattern of 21. Take that pattern and write it under your subnet bits. Imagine you cannot see anything but the subnet bits. Put on the glasses, but see only red. Can only see those bits. Take that pattern and write it there. 1, 0, 1. In this case, don't look at the boxes, look at the subnet bits. So, 0, 1. Now we have the number under the subnet bits. But we need 8 bits in each box, so add zeros in front. Okay, what we're finding right now is the network address. Finding the network address, we know, if you can't remember, take a look at your subnet encrypt sheet. All host bits are 0 in the network address. So, put zeros for host bits. Then, take a look at your boxes, figuring out what is the actual number in each box. 2.
The other one is 160.
2. This box is 160.
0.
This box is 0. Oh, my 10 from up here are network bits, so they do not change. Just write them here. Which gives me in total, the network address of the 21st network is actually 10.2.160.0. That is my network address of number 21 network. We can easily find the first usable because it is the next address. Add 1 to the rightmost number, becoming 10.2.160.1. Add 1 to the 0 here. If it's a 32 up here, add 1 to 32. It's a 64. Add 1 to 64, and so forth. Take the rightmost number and add 1. Okay, broadcast address. Broadcast address. Remember, we need to find the broadcast address in this network. That means those network bits need to be that pattern, nothing else. If it changes, it's another network. So simply copy the bits. That is your network number, must not change under any circumstances. So, but you do know also, your host bits in your broadcast address is always ones. So, change your host bits to ones. Now take a look at your bits as they are in the boxes. This one is still 2. Second one changes to 191 because 116 plus all host bits 31 gives me 191. All host bits are set in the last byte to 55. The first byte is all network, still a 10. I have my broadcast address. 10.2.191.255. Last usable is the address just before that. Subtract 1 from the rightmost number. 254. My last usable address is 10. That error is actually one of the most common errors to do. Start changing this one from here to here. That is wrong. We're not changing the thousands or in the 256 or whatever you call it. It's a higher bit. Do not touch it. That's basically it.